The upper threshold. Okay, so any questions before we get started today? Everyone have to register your spot for your midterm 3. When would you be able to reserve a spot for the final? Is that the next week, right? Okay, so make sure you do that too. And then a few things that's going to happen very soon in the next couple of weeks. First thing is that there is another point coming from me by doing the final evaluation, right? So I will post the assignment this week. I think it's open already. Okay, so all you need to do is okay, just go and do the final course evaluations, screenshots that you finish the evaluations, and upload the assignment, and then you get 1 point from me. Okay, so that's, I think, easy points that no one should actually miss. Okay. Second, we'll still have the partial credit for the midterm 3, but not for the final. Okay, because there's actually no time for me to give you time to actually do the partial credit for the final exam. Okay, I have to submit the later grade soon. But we'll still do it for the midterm 3. Okay, so again, it's the same thing. After you come back from Thanksgiving, then you start to do your midterm 3, right? So that is actually the week after, the next Tuesday after the week will be the due date for your partial credit for midterm 3. Okay, all this will be posted on Microsoft Teams, so pay attention to that. Okay, what we are going to do today is finish chapter 18. Okay, so the 1312 is designed in a very special way that they want you to learn part of chapter 18 before Thanksgiving and learn a little bit after Thanksgiving, and then all the things plug into your final exam. Okay, so based on the design, the things we taught this Tuesday will be all the content you need to know for midterm 3. Okay, the things we're going to learn today, which only maybe just 5 hours, will cover all the things that you need to know. Okay, and there will be extra things that they want to test you in the final. Okay, so instead of actually copying the things into pieces, I would suggest just do the things that what we are doing now. Okay, learn everything. Okay, you finish, everything will be covered in midterm 3. Okay, and then they will actually help you to enter this final exam preparation mode easier. Okay, so what we will learn today, okay, make sure you learn it. Okay, don't let it behind. Okay, we just learn everything today. And then the remaining 3 lectures we really dive going back and then review the key concept, key equations. Okay, and then I think that's actually the best way for you to prepare your final exams. Okay, so talking about that, I guess right now everybody should actually get a sense what will be the most effective way to prepare your midterm and final, right? So again, the things that's really essential is your quiz, my questions, right? My video is actually a great source to actually understand how you actually solve those problems. Okay. then your practice midterm 3 is very important. Okay, so make sure you actually comprehend and can do everything quickly for your practice midterm 3. Okay. If you have friends who happen to have the old practice midterm 3 questions, get all things too, because all these things coming from the same data bank. Okay, so the more you practice, the better you are prepared. Okay, so that's how you prepare for your midterm 3, right? How to prepare your final. It's going to be very similar. Okay, you want to be as efficient as possible because there's multiple finals that you have. Okay, so what's the most efficient way? First, come to the in-person review lecture here. Okay, we're going to go through a bunch of questions. Okay. Second, get all your exams, midterm 1, midterm 2, midterm 3. Okay, go through all things. Okay, and then I hope you have some friends. You can actually exchange the questions. Because everybody gets different questions. Okay, but if you have like 3 friends, you just try to figure out what other things that's different or what other things that's constantly appear, right? If it's like a constant appear, it's actually something that's so important that it will appear again in your mind, right? So do that. Okay, and then I think let's do a practice final exam. Okay, and then after you feel like you are more or less ready, okay, be very honest with yourself, just your calculated and then you are capable in bound of constant. Okay, time yourself. Make sure you finish early enough. Okay, so by doing that, I think you will be more than prepared for this course. Okay, so you guys will see that I emphasize a lot about the approaches, methodologies, right? And this has nothing to do with your CHEM1312, but this has great relevancy to how you do your things in the future. Okay, if I want to actually take this away with you, okay, after finish these courses, okay, usually you know how to handle all the knowledge quickly. Okay, you guys in a very interesting generation, I feel. Okay, AI just coming out. Okay, now it's around 4-5 years only. Okay, but our lives has been greatly changed. Okay, so one thing that you need to be good at in the future will be the skills that you will need for you for the life that you want to have. It's going to be very different from my generation now. Okay, so don't just listen to what your professors. Okay, think yourself. It's very important. Okay, you guys are adults. Okay, so on day 1, I tell you, I respect every single student as adults. Because I think you actually starting entering a stage that you need to think for yourself. Okay, you're not kids anymore. You should not actually just listen to, you should not just be bad with all the information from someone that looks comfortable. Okay. We are all trying to excel in our life, right? Everybody has their own dream. Okay. How can you actually achieve that? Should always be your #1 goal, right? So how do I define success? Okay, I got asked a lot by many students in the past. Okay. I have many students who come to my office. They're asking questions for 10, 13, 12. They're not asking any like course related questions that explore like personal life advice. Because they feel like the things I say make sense to them. Okay. And I also like to share some of the things I think is really important for your generation. Okay, so AI is real thing. It is not something not real. Okay, so stop doubting that. Okay, spend your time wisely. How you can be the winner among this game. Okay, I always think that. I guess many of you can see I'm a very optimistic person. Okay, I always look things from the positive side because that's the way I feel. That's actually the only way to figure out the answer. Okay, if you think negatively, you'll never figure out the answer. Okay, so stay positive is very important. Okay, so mindset is important. Okay, but with a proper mindset, the things you need to actually do is think about how you can actually improve yourself. Okay, because when it comes to me, one of the questions I got a lot is actually how do I define success? Okay, and my definition is actually very simple. You ultimately live a life that agrees with your imagination, which is very difficult. Okay, for example, I want to be a billionaire. If that's actually my dream, I need to actually reach that, so I can define I'm successful, right? But if my goal is just okay, I want to have a small shop, okay, maybe a small coffee shop. I can do the coffee every day. The smells and feel good about it. That's wonderful too. Okay, so everybody has different dreams. Okay, I value everybody's dream equal. Okay, but the goal, I mean, there's actually common pictures after that, underneath that, right? It's very realistic. You live the life that you want to live. Okay, so in order to do that, then everybody has different challenges. Okay, that's why we also pick different majors. Okay, so how do we actually can play this game well? Is that you need to actually pick up the key information quickly. Okay, and then anything is endless. Okay, you can always be better, always. Okay, and you should make yourself a better you every day. If that's the things you found every day, you feel good about yourself, actually. Okay, so make sure you form a positive feedback loop for your life. Okay, and then I think you actually really enjoy this journey. Okay, it's not very long, maybe 100 years. Yeah, maybe go through your time, maybe actually study longer, but I don't expect it's going to be like 10 times longer. Right. So using your time wisely is very important. Okay, and then have strategy. Okay, in order to have strategy, have a goal first. Okay. And then know how to actually do things properly and efficiently is very, very important. Okay, so I hope the things I've demonstrated you so far, carry with you. Okay, and apply to what we're going to do in the future. Okay, so how many other things you want to learn today? Chapter 18, there's actually not much left. Okay, so on Tuesday, I tell you how scientists using the particle decay to estimate the age of a subject, right? So the equation we use is very simple. Natural log AT over A0 equals negative KT, right? The things that's difficult is actually to have a clear idea about how you're going to get the AT and A0 properly, right? And then we tell you you cannot use mass if you use number of particles or number of moles, because decay is a one-to-one process, right? So that's actually another thing that after the lectures, there's a student come to me. They say they're not quite clear about this decay. What does it mean? Okay. So what does decay means? It means actually if you have the substance A, okay, after decay, it's going to become substance B. Okay. You still have A. You don't. The A is gone. Okay. So let's say you have one A undergo beta decay, forming the substance B. Okay. So after the decay, you don't have the A anymore, or you have to cycle one B. Okay. But if today you have 10A to start with, okay, if I say 3 of length, 3 of A have decayed, it means actually at the end, you're going to have a 3B and 7A, right? This 7A will be your A T, right? At this time, you have 7A. But the way you get your A naught is by adding up the number you got from A and the B. In other words, the undecayed and the decayed product, right? When adding up, then you have your A0. Okay, so that's actually all the things we talked about on the very last example Tuesday. Okay, So once you can get the idea, then those kinds not the actual issue for you. Okay. The questions that still always confused is that I don't know how to get my AT, I don't know how to get my A0. Okay, so that's a confusing part. And what we're going to do today is trying to, okay, most of the time you will just hear me talking about some of the knowledge that you can get by reading the textbook. Okay. So the very last equation that we want to actually learn is to calculate the reference distance called the mass defect. Okay. So then you're going to hear two different things. Okay. So it's the mass defect was defined as the differences in mass between actual and hypothetical mass of a nucleus. Okay. So what this means is that if today I give you one atomic symbol, for example, I have PB206. Okay, so PB has a proton number. You have periodic table. What's the atomic number for PB? $82. Okay. So from here, we know you have 82 protons, right? And then you have 206 minus 82 equals to 124 neutron. Okay. So if I give you atomic symbol, you'll just be able to figure out how many protons do you have, how many neutrons do you have. Okay. Then scientists have determined the mass of a single proton and single neutron. Okay, so we have a unit called the atomic mass unit. Okay, so one proton is going to give you a 1.00 something AMU. One neutron is going to give you another number of AMU. We're going to that constant afterwards. Those are the things we are going to see. Okay, so scientists determine those numbers. So since right now, if I give you an atomic symbol, you know number of protons, number of neutrons, right? Then you can just do this weighted sum, right? So number of proton times the mass of proton plus number of neutron times the mass of neutron. By calculating that, you got a hypothetical mass of that specific atom. Okay, so that's that hypothetical, right? Then essentially you're going to have the real determined one, right? You can really measure the mass of the atom. Then you're going to get another number. Okay, so very often scientists observe these two numbers, okay, they don't fully agree with each other. There's small differences. Okay, so they call that differences in mass as mass defect. Okay, we're going to give you an example to purchase this. Okay, but that's actually the idea about mass defect. Okay, then scientists start to think about why we have this mass defect. Okay, so later on, the conclusion is that they lost part of the mass into energy. Okay, so those energy we call it as binding energies. Okay, so some of the particles, even smaller particles than your proton and neutron, okay, got released from your atom. And that release actually give you a lot of energy. Okay. And the energy related to that mass defect. This is very famous equation, right? The change in energy equals to the delta N times C squared. Okay, this is actually the equation that you must learn since you're very young, equals to mc squared, right? So it's actually specifically describe this behavior, okay? How the energy that released from your nucleus is related to the loss of the mass, okay? So a big part of the remaining calculating is to calculate that delta E. Okay, so let's actually allow different units. And the things you actually be careful is really pay attention to a unit so that you know how to calculate the things properly. Okay, so that's pretty much the concept that you need to know. Then we'll need to actually practice this using examples. So questions is very, very long, okay? And then inside the question that's actually about the concepts. Okay, so when students actually just see this question, they just give up. That's typically what I do. Okay, but it's actually much simpler than you saw. It's more like the unit conversion type of questions. Okay, so let's read the things and find out the keywords. It says an atom has a mass of certain AMU. Calculate the binding energy in mega electron volt per atom, mega electron volt per nucleon, mega electron volt per mole, kilojoule per atom, kilojoule per nucleon, kilojoule per mole. Use the following information. The mass of your proton equals to certain AMU, mass of neutron, certain AMU, speed of light, and then they actually repeated this twice, so you don't need this. Speed of light, and then it tells you how the AMU is related to the kilogram mega electron volt. Okay. Give your answer to 4 significant figures and do not use E notations. Okay, so a lot of description over there, right? But what is actually a keyword? The keyword is this. Okay, so when we say this E equals to mc squared, right? Let delta E, its official name is binding energy. Okay, so every time you see this keyword binding energy, then you know that it's actually the go-to equation. All right? So how do you actually calculate the binding energy? You have to actually calculate the delta M, right? So this is actually the mass defect. Okay. So you need to calculate the mass defect. Then you times your mc squared, then you pay attention to the unit, and that's it. Okay. But the things I want to describe or discuss a little bit more about is that pay attention to the unit. Okay. So there's actually multiple things we want to calculate, right? The first one is mega electron volt per atom, right? The second one is mega electron volt per nucleon. And then the very last one is mega electron volt per mole. Okay, so let's actually accept, right? Because you use mega electron volt. And then, so this actually accept. Then the next set is kilojoules per atom, kilojoules per nucleon, and kilojoules per mole. Okay, so apparently you should see that mega electron volt is actually unit of energy. Kilojoule is also the unit of energy. Okay, so these two sets is actually equivalent. Okay, so suddenly you feel like the question seems like it become much less. Okay, once I figure out one set, the next set is just unit conversion, right? Okay, I start to look at this per atom, per nucleon, per mole. So what's the differences? Okay, per atom is what? It's a single atom, right? What's the difference between the per atom and per nucleon? So what is nucleon? Nucleon is actually your proton is a nucleon, your neutron a nucleon. Okay, so per nucleon means actually if an atom you have 10 protons, okay, 5 neutrons. Okay, therefore then you're going to have a nucleon of 15, right? 10 plus 5. Okay. So the sum of your number of proton and number of neutron will give you number of nucleons, right? But what is actually the sum of proton and neutron? It's actually your mass number. Okay, mass number is actually the things that is equal to the sum of proton and neutron, right? So to convert these two, all you do is actually you divide this by your mass number. Okay, so if you whatever number you got in the first row, you divide by the mass number, then you got the makeup electron per nucleon. All right, so it's very simple, right? So just a conversion. How about this? Makeup electron volt per atom to makeup electron volt per mole. What's the differences? Yes, that's our Avogadro number, right? So all you do is actually just multiply the Avogadro number, which equals to 6.02 times 10 to the 23rd, right? And you're going to get the answer. Okay. So the big structure is actually very simple. So don't get scared. Okay, if you just do some simple analysis, then you realize it's not like that. Right? All I need to actually both sides actually first, okay, get the mega electron volt atom. Right. And then divide by my mass number, I got the second answer. Times the Avogadro number, I got the third answer. Okay? So it's not like that. Okay. So now how do we actually get the mega electron volt per atom? Okay. Then we need to actually go back to this, right? Because this. Okay. So C squared, okay. The C, of course, is like a constant. You already know that. Okay, it was provided already, right? So you don't have to worry about the C. Now the things you don't worry about is actually how do I calculate my delta N? Right? So the delta N is the hypothetical mass minus the actual mass. Okay, so that is actually things that you need to calculate. Okay. So actual mass, you have the actual mass from the description. It tells you an atom of indium 222 has a mass of certain A and U, right? So once after you see that description, that is actually the actual mass of the atom. Okay, so you know here you will need to minus 121.91028 AMU, right? So that's actually how you put those things into a proper location. Okay, so now essentially we know how to calculate the hypothetical mass, right? The hypothetical mass is calculated to a very simple things, right? It's actually a number of proton times the mass of your proton plus number of neutron times the mass of your neutron. Okay? So what is actually the mass of your proton? It's actually defined here, right? Do you see this?
The proton atom has the mass of 1.007825 AMU. Okay, that's actually, if you have one proton, that's the mass. Okay. Similarly, mass of your neutron is 1.00A665 AMU. Okay, so your neutron is slightly heavier than the proton. Okay, so those are the things that you need to put here. Okay, so the mass of your proton is 1.007825. Okay, times mass of your neutron is 1.00A665. Okay.
So the only thing to remain is that you need to figure out what is actually the proton number and your neutron number, right? So
then you look into your atomic symbol, which is Indian 122, right? So first, go back and check out your periodic table, right? So what is actually the proton number for your Indian? 49. Okay. So you know you have proton number of 49, right? Therefore, your neutron number will equal to your mass number 122 minus 49. They give you 73. Okay. Therefore, you put 49 for your proton number, 73 for your neutron number. Okay. Then you can get your hypothetical mass.
okay, so once you can figure out what your hypothetical mass, you subtract the actual mass. Then you're going to get a value of
1.1057 AMU times C squared.
okay. So here, for this calculation, okay, pay close attention to the unit, okay, so it's a kind of like unit matching game. Okay, so we start from AMU times C squared. Okay, so right now you take the unit here.
Okay, so let you know the binding energy of this guy will be this, right?
So what calculate this value? This is the value for a single atom. Okay, it's a single atom calculation. Okay, so this actually is actually the things, the first information we want to get, right? Per atom,
What's the value of that? Okay, but here we want to start to match the unit.
right? Here it's actually AMU times C squared. But
The unit you want to have is what? The unit you want to have is what? Mega electron volt, right? So how do you actually convert it? You see this? 1 AMU equals to that. Okay? That's the things we want to use. Okay. 1 AMU will equals to 931.5 mega electron volt per speed of light square. Okay? So if you do that, it's 1.1057. 1 AMU is 931.5 mega electron volt. The speed of light square times this. Okay, so I can actually substitute my AMU and substitute this guy into this whole thing. Okay, then I change my unit, right? So after you do this, then this and that will cancel out. Then you end up with a value of 1029.9 mega electron volt. Okay.
So here,
you should also know that this is actually per atom, right? So we start from the one atom, we calculate the proton and the neutron to calculate the atom mass. So all the operation is at the single atom level. Okay, so sometimes from the unit you may not see this actually a single atom, but you need to know that. Okay, so let you get this number. So this will be actually the number for this one, right? This actually 1029.9 mega electron volt per atom.
okay, so that's actually the first one. So once you figure out the answer of the first one, then you can actually know the answer of the second one
By divided by mass number, right? By divided by 122, then you get your second answer. Okay. If you multiply this by the Avogadro number, then you get your third answer. Okay. So even though the question looks very complicated, it's not. Okay.
the things is actually you usually know how to calculate your hypothetical mass. Okay, and you should know how to do the energy conversion properly. Okay, then all these things will be actually quite straightforward. Okay, those three different questions is basically the same. You just have to multiply or divide by certain numbers. Okay, so any questions for this? Okay, so
That's how you address these questions. Okay, so you can go home and practice of the remaining one. Okay, but it should be actually quite easy. Okay. All right. So let's actually the important calculation part for chapter 18. The very last things that we want to learn for chapter 18 is something called the synchrotron and some other thing called the nuclear power station, and that's all. Okay, so I summarized the key message that you will need to know. Okay, so the first one is actually the particle accelerator. Okay. Does anyone actually go to National Lab and really see how big the particle accelerator is? So why distance is needed? Okay, so particle accelerator is actually an instrument. Okay, that's crazily big. Okay, so we have actually a bunch really state-of-art particle accelerators in the US. Okay, the most and the best one I think is actually in Denver. Okay, they have this thing called a SLAC. And what they do is actually they accelerate the particle. Okay, the particle they want to accelerate is because you want to really see these nuclear structures. Okay, the energy that they are involved is crazily big. Okay, so you actually have a very powerful particles to hit those unknown or target atoms, so you can understand its property. Okay, so the most commonly used particle that got accelerated is the helium-24. Okay, why? Okay, assuming you are a scientist, okay, you want to pick something that can get accelerated. Okay, so what will be actually requirement for that? How to accelerate a particle? Yes, has to be light and stable, good, and you guys are very good. Those are really two very important criteria, but there's actually a few more. How are you going to accelerate it?
Huh? Okay, so you use electric field to accelerate it. Okay. Yeah, you actually build a really big accelerated channels. Okay, and inside there just great pieces of magnets and electric wires that keeps together in a way that you always provide electric force and magnetic force to force the particle to go along the single direction. Okay, it's always have this round shape because it's going to be doing the same thing over and over again. Okay, that's why you see all the designs actually circular. Okay, so you are going to use electric field to drive the movement of a particle. Okay, therefore your particle has to be charged. It cannot be neutral. Okay, so it will be light, it will be stable, it will be charged. Okay, who will be the candidate? It will be your helium. Helium is actually the smallest atom that we actually have. That's charged, that's stable, that's small. Okay, so the think of this one is actually for us, just like the very practical consideration. Okay, so every time you see people trying to use the particle accelerator to accelerate particles, okay, it must involve the helium particles because they will be actually the substance that we can actually use. Okay, so every time you see the particle accelerator, looking for the equation as helium 2 they will give you an answer. Very simple. Okay, and that's kind of the biggest things that you should know. Okay, the other thing that you should know is that
when we're trying to say something is actually undergo we're trying to actually use the particle accelerator to study it. Okay, so you will see something a symbol like this.
Okay, so the X, A, Z is actually just a general representation of our atomic symbol, right? Let's say I want to study Indian, that, okay, then you put those atomic symbol in the very beginning. Okay, that highlights the things they're going to be studying. Okay, and you're going to see this parenthesis. Okay, and inside parenthesis you see there are two different particles. One is helium 2 one is actually a neutron particle, right? So what it means that I'm going to hit that unknown particles with my helium.
Okay. So the first one is actually describing what's the particle you're going to use to hit the unknown particle.
Okay.
And then the second one tells you once I hit that, I'm going to generate a new species and also some
particles. Okay, so the second one is actually going to tell you what particles are generated after this reaction. Okay, so one of the questions you're going to encounter in this chapter is that they give you this.
They give you this. Okay, then they want you to write out what's the information of the Y.
Okay, so again, this actually, if you know what the notation means, okay, then you go back to a very simple equation, right? The mass number of your reactant has to equal the mass number of your product. The total number of your reactant has to be the total number of your product. Okay, that's actually the question we find is on Tuesday. Okay, so that's actually one thing that you need to know.
Okay, and that's pretty much it for the particle accelerator. Okay. The other things that we want to actually learn, okay, for this specific part, I would suggest,
if you are really interested in the content I described today, then maybe spend 30 minutes to read the textbook. Okay, it's kind of, this part actually a lot of description. Okay, there's not much calculation involved. Okay, so if you want to really know the details, reading a textbook could be actually a good way to comprehend that material too. Okay, and it's short, so I would suggest that you can go and read it. Okay, but what are the key informations?
okay, the first thing is actually to know for the nuclear power station to work, okay, there are two different types. One is the fission, one is actually the fusion. Okay, so the fission means actually you break things apart, fusion means actually putting things together.
Okay, so either way can generate a great of energy. Okay, but technically, the only thing we can do more or less reliably is actually the fission, not the fusion. Okay? So we need to know the difference between fission and fusion, and currently, this is actually the major way that we generate the energy in our nuclear power. Okay. You also need to know how these things work. Okay, so inside the nuclear powers, you're going to see a structure like this. You're going to see a things called breeder reactors. Okay. So what it does is that inside these big reactors, so let me draw something like this. Okay. You're going to actually use the neutron to heat this reactor bar, okay? The nuclear bar, okay? So these bars is typically is actually made out of non-fissionable U-238. Okay, so what does that mean is that this guy by itself, it doesn't actually break apart into small pieces to generate energies. Okay, so it's actually relatively stable. Okay, but once this guy was hit by the neutron, okay, then many decays going to occur. But the end result is that you're going to produce something called the photon 239. Okay, this guy, and of course, a bunch of neutrons associated with this. This guy is fissionable, meaning that it can actually break apart, release energy, produce more neutrons. Okay, so the reason you want to have this design is because you want to generate, because you actually have a stable cell to start with, right? If the things that you're not stable in the beginning, it's very difficult to assemble them in a safe environment, right? Therefore, the design will be, okay, I have a very stable one first. Okay, but this stable one can be converted into the non-stable one to produce energy afterwards. Okay, so that's actually the basic things that we should have in mind first. Okay, and the way you convert this non-fissionable U-238 into fissionable Pu-239 is using neutron creation. Okay, but once you do that, you're going to produce a bunch of neutrons, and those neutrons will come back and hit the U-238, and this thing will happen over and over again and escalate. Okay, so what happens if things actually escalate too much? It's going to be out of control, right? Yeah, they're going to produce a lot of energy, a lot of heat. Okay, then eventually going to melt down your power plant, which is not something that we want. Therefore, in this breeder cell, there's actually another thing called the control rod. Okay. So these things or the control rod. Okay, typically control rod is made out of silver, indium, and cadmium. Okay, so those are the major composition of your control. So the main thing of the control rod is to absorb neutrons. Okay, they're actually very efficient to absorb the neutrons. Okay, so when you feel like, okay, I want to get constant neutron hitting my U-238 to produce energy, right? But once this goes on, you have to produce more neutrons. So you have to actually counterbalance that. And the way we counterbalance that mechanically is that we start to actually lower down the control rod into your field. Okay, so it absorbs all the neutrons. Okay, so you can just stop the reaction.
Okay, so it's actually a delicate balance between these two processes that eventually give us a stable energy output. Okay, so key information here is actually to know what is U238. U238 is a non-fissionable fuel for the breeder cell. Okay, and the way you can actually activate U238 is actually by neutron collision. Okay, once you have that, then you convert the U238 into something that becomes fissionable. Okay, and then to compensate too much neutrons inside your breeder cell, then we use this control rod to absorb the neutron to slowing down this conversion. Okay, so that's actually the basic principle of our nuclear power plant. Okay, so very simple story. Okay, but there's actually a lot more details in your textbook. If you are interested, go ahead and read it. Okay, but that's actually the fundamental ones. Okay, so the question you're going to encounter in this chapter is actually very simple. Okay, it will be something like this. You'll just give you a bunch of statements and actually pick up the correct one. Okay, so in this specific question, the first one is that breeder reactor convert the non-fissionable nuclei U238 to a fissionable product. Okay, yes, that's actually the main working principle, right? U238 is the stable one. The breeder cell needs to actually convert into the non-stable one, so it can produce energies. Okay. The second, the control rod in the nuclear fission reactor are composed of substance that emits neutron. So apparently it is not emits, right? You want to actually absorb, right? Okay. The third one, electric power is widely generated using nuclear fusion reactor. No, it's not fusion, right? It's the fission reactor. Okay. So it's like statement like this. It's all kind of very straightforward. I can know the basic principle of how these things work. You know, you have no problem answer these things properly. Okay. Very last one. Which one of the following require a particle accelerator to occur? Right. So we spend a lot of time thinking about what particle can be accelerated by your particle accelerator, right? And I say looking for helium-2 because that's actually the positive, stable, and small particle we want to use. Then you look at all these equations. See this guy? That will be actually the answer you want to use, right? And then this guy has to draw on the reaction side. Okay, it's actually you heat the unknown particle with your helium-2. Okay, so that's how you actually find out the answer. All right, and that's pretty much it for chapter 18. Okay, not too bad, right? It's actually very simple compared to the previous chapters. Okay. All right, so what we're going to do now is that we still have around 20 minutes. Then I want to actually review chapter 16 and 17. Okay, so these are the equations that you need to actually memorize for chapter 16. Okay. So first thing first, chapter 16 is the things we start to introduce what? Entropy. Right. So the first things that you need to know is if I give you a substance, can you tell which one has larger entropy? Right. So base idea, the first rule I wrote here is actually the entropy of the gas is way, way, way larger than the entropy of your liquid. And then entropy of your solid. Okay. Is this good? So
Nothing special, right? If you know it, you know it really. And then the second thing is actually, we should know that the delta S universe is composed of delta S system and the delta S surrounding. Okay.
And then delta S surrounding can be replaced by delta H over T. Okay, negative delta H over T. Okay. Then the things you do next is that you multiply next P on both sides. You end up with this, and this. Okay.
And the beauty of doing this is that if you look at this delta H, delta S, it's actually the property of your system. Therefore, you can just simply look at your system and you know whether the things is going to be spontaneous or not, right? So we define that negative T delta S universe does have delta G.
Okay. So the really important equation you want to memorize is this guy, right? Delta G equals to delta H.
Minus T delta S. Okay, the delta H and delta S in this specific equation, they're actually the property of your system. And so this one is being memorized. Okay.
In this chapter, you are going to be asked, I guess the key concept that we should actually memorize is that for a spontaneous process, every time you see spontaneous, right, that means your delta S universe has to be positive. Delta G has to be negative. Okay? I guess I also want to put the delta E inside. Right? The cell potential
Has to be positive, so it becomes spontaneous. Okay. So here I start by explaining some of the information from chapter 17. Because I think it's actually relevant. It's easier to actually just memorize all in one single places. Okay. So
these are the three things that you need to know. Every time you see the word spontaneous, right? Delta S universe has to be positive.
delta G has to be negative. Delta E cell has to be positive. Okay.
Then the equation that I want to memorize is this. The delta G naught. Okay, don't omit the naught. Okay, you have to have
That little circle on the top right corner. The delta G naught is going to be equal to negative RG natural of K. Okay. So
one thing that we need to learn from this is that if your K equals to 1, if your K equals to 1,
your natural K term will become natural of 1, right? Therefore, natural of 1 equals to 0. That means that your delta G
will equal to 0. Okay? Now think about this. If your natural of K, if your K is larger than 1, K is larger than 1. Okay?
then your natural K term will be positive. Okay? Therefore, your negative RG natural K term will become negative because R is just a constant. Temperature is in Kelvin. It's always positive. Okay. So under that condition,
then you know your delta G naught will become negative. Okay? So similarly, if your K is smaller than 1, then your lnk will become negative, right? With the negative RT, the whole term become positive. Therefore, your delta G naught will be positive. Okay. Everybody understand what I'm talking about?
it's really kind of, you use the math equation to see what it implies. Okay, so you put in different K, right? And then analyze the sign of that the negative RT natural K term. Okay, then you realize, okay, sometimes you have the K larger, equal, or smaller than 1. your delta G will have to have the associate sign as well. Okay, so if you don't understand what I'm talking about, then just memorize this.
Okay, the second one is actually delta G equals delta G naught plus RT natural log Q.
Okay, so this is actually a very typical questions in chapter 16. Okay, every time you see a question start to describe the specific pressure concentration of your reacting sub and products, that's an implication that you need to calculate your Q. Okay, and this is the only equation that's Q inside. Okay, delta G equal to delta G naught plus RT over Q. Right, so this will be your go-to equation. Okay, and then delta G naught, okay, is associated with the previous equation, right? Equals to negative RT over K. Okay, so you're going to get those informations from the description in the questions. Therefore, you can calculate your delta G. Okay.
Yeah, so very similarly, this is also the things that you can see. Okay, so you can consider this. Right, so I just replace this one with this guy. Okay, then I can rewrite this. Okay, so you can see the structure of this is
Two terms. The first term you have K, second term you have Q. Right? And then the first term there's a negative sign, second term there's a positive sign. Right, that's actually what you see in this equation.
okay. So essentially compare the K and Q. Okay, whoever is actually larger, who is going to dominate the sign of your delta G. Okay, so I guess easy way to memorize this is okay. Q and K, right? So if a larger Q, smaller than K, then the second can dominate since it's positive, therefore it's positive. Okay, you can use the same analogy for the remaining ones.
Okay, so you know if you understand then your delta G is 0. Okay, but if Q is larger than K is smaller, then delta G is actually
The Q is the delta G will be actually positive. Okay, so that's actually how you can actually memorize this relationship. Okay.
and then after this, it will be your how to relate delta G naught to your E naught cell. Okay, so
You should see the equation, they're actually all very similar now. These two, you look at their structure. If you want to relate to your equilibrium constant K, it's negative RT ln K, right? And this is negative NF E naught cell. Okay, so that's the definition. Okay, and then by comparing those two, then you can actually further relate your E naught cell with your K, and then E cell with your Q. Okay, so these are important equations that you must actually memorize. All right.
so this slide, I mean the things we just described here actually summarize all the three equations that you need to memorize for chapter 16 and part of 17. Okay.
So this will be actually the summary of chapter 17. That's too long, so we just go through this one by one.
Okay, so something that you first thing that you remember about chapter 17 is first thing to know what is galvanic cell. Okay, galvanic cell is also known as a vortex cell, right? So they use the spontaneous chemical reactions to produce electricity. Okay?
So for the galvanic cell, you should know that your E naught cell has to be positive. And the way you calculate your E naught cell will be your E naught oxidation and the E naught reduction, right? You add it up, then you can get your E naught cell, right? So you get your E naught oxidation from your LoRa. You get your E naught reduction from your G rock. Okay. You should also know that all the notation and structure of this electrochemical cell, right? So you should know what's LoRa, what's your G rock. Okay. And here you should know what is your anode, what is your cathode, where is actually your soul bridge, how the electron is actually flowed. Okay, the electron is actually flow from your anode to your cathode through the wire. Okay, and then inside there, there's electrolyte. You should also know how to write the cell notation. Okay, so the cell notation will follow this A, B, C structure. Okay, you start from your anode, soul bridge, and then your cathode, right? So here, there's actually one thing I did not discuss specifically when we're actually talking about the cell notation. Okay, sometimes you will see that right now your reactant product with anode with a straight line in between two substances. Sometimes you see commas in between, right? So the difference between that is that if the phase of your reactant product, they are not the same, you use straight line. Okay, for example, zinc to zinc 2 plus. Okay, so zinc is in solid form, zinc plus is in the aqueous form. They are in different phase, then you put the straight line. Okay, but if today is Br2 to Br minus, okay, Br2 is liquid. Okay, Br minus is in aqueous solution, also liquid. They are in the same phase. Then under that condition, you use a comma to separate these two species. Okay, and the other thing I did not mention clearly previously is that sometimes you will see this on the two ends. Okay, the PT/C. Okay, C stands for column. Okay, so what does that mean? Because sometimes when we run this redox reaction, the substance you use cannot be used as electrode directly. Right? For example, your Br is in liquid form. You can use Br2 to serve as your electrode, right? So you have to insert some inert electrode to form the loop. Okay, so the most commonly seen is actually the platinum/carbon. Okay, and since they're actually in the solid form, your reactant is not solid form, therefore there's always a straight line in between those anode location and cathode location. Okay, so those are the things I feel like I did not make it very, very clear, but that's what it is. Okay, so the galvanic cell, the structure, how to calculate your E naught cell are the first big things for the chapter 17. The second thing that's actually very important is that you have a good sense now, the redox balancing, right? So redox balancing, when you do this type of question, you will always specify you have acidic or basic solution. In the acidic solution, if you are missing oxygen, you use H2O. If you are missing if you're missing H, use H plus. Okay. Basic solution, if you are missing H, use H2O. If you're missing one O, you add in 2OH minus. Okay. So those are the very important things that you need to know. Okay. The procedure wise, we follow this 4 steps, right? First, assign all the oxidation number, find out who is your LoRa, who is your G rock. Okay, and after that, then you try to balance all the atoms. Okay, so when you balance atoms, I think there's actually a few things you also want to follow. Right. So the first step is always balancing the one that undergoes the change of the oxidation number. Okay. So once we balance that, then you start to look for other atoms. Okay. Once other atoms, sometimes the one that you are missing is not oxygen, not hydrogen. Okay. So balance those things first. Okay. So and then you balance your oxygen. Then very lastly balance your hydrogen. Okay, so there'll be actually the flow chart. Okay, how do you select which one to go next? Okay, so start from the one that undergo the oxidation of the change. Then go to the non-oxygen, non-hydrogen atom. And after that, then doing your oxygen and doing your hydrogen. Okay, then you're going to balance your atoms, right? And after that, then you use the electron to balance the charge. Okay, and after you balance the charge, then you make sure the electron generated by your low rock is equal to the electron outside by your G rock. Okay, once that's actually satisfied, you just add up the equation. Then you get your final balance to redox reaction. Okay, so those are kind of the things that you need to know. Next, we come to this electroplating, right? So this is actually the only equation that you need to memorize for the electroplating. Okay. The grade of the product is going to be equal to N is actually the current times S is the time, right? Second, divided by N is actually the number of electrons you need to produce one product. F is the steady constant. Okay. Times the formula weight of the molecular mass of your product. Okay, so that is actually the equation that we need to actually memorize. Very last one, electrolysis. Okay, so electrolysis is actually the inverse of your electrochemical cell, right? You exert the electricity into a solution. Okay, and then basic idea is when you do the electrolysis, K-ion goes to cathode, anion goes to anion. Okay, and then cathode you still have G-rock, anion you still have low rock. Okay, everything's actually staying the same. Okay, and one of the things that will ask you, okay, is going to answer these true and false questions, right? So you can ask you, okay, what is going to be electrolyzed at a specific electron, right? So you can find out the species with the less negative, either the reduction potential or oxidation potential. Okay, so that's actually a basic idea. Okay, and if you have mutant salt, that's very simple, right? Mix mutant salt, find the less negative one. Okay, but if the aqueous solution, then the raw water also will be taken into account, right? Then you just have to consider the reduction potential and the oxidation potential of water. Okay, so those are things that you will need to actually get familiar with. Okay, so these are all the information you need for chapter 17. Okay, so I think I'm out of time. So we're going to review the things that for chapter 18 before we finish all the review portions next week. Okay, thanks.